What's up, everybody? It's me again. Same night. This is like just the second video I'm doing. So here's the question. You guys hopefully have already read it, so you know what's going on. This is 11.2. We're talking about the muscle bone. So you just want to draw this guy out again. So I'm going to do that real quick. We've got this guy right here. So we can scroll up so you can see a little better. Oh, too much. Didn't need to go that much. Okay, so you've got C, you've got T. Now these are the forces, remember. Going up and R going down. So this is kind of like drawing a free body diagram, which makes it kind of easier for you guys to see. And then you got 3.5. Remember, this is centimeters. And then you got 7.5 centimeters. Okay. So it says, what does it ask? It asks, find T and R if you bite down on a piece of steak with a force of blank, whatever your force is. The force that they gave me was 52.8 newtons. So what I'm going to do is this. It's called the sum of torques. We did this in the last problem. Sum of torques. That's the best T I can do right now. So what we're going to do is 52.8. Now what is torque? You take 52.8, which is this force, and you multiply it by oh man, I'm lost. Sorry, you multiply it by the radius. So what we're going to be doing is keeping this, and this is going to be our pivot point, because we need a pivot point when we're talking about torques. So 52.8 times 0.11. Now why do we do 0.11? Well, 0.35 plus, or excuse me, 3.5 centimeters plus 7.5 centimeters is what? It's 11 centimeters. But guess what? We always work in meters, and it's 0.11 meters. Wait, where do we see this? Oh yeah, right up there. So, perfect, and that's away from the, what's it called? The pivot point. 0.11 centimeters away. And we do, so we're going to do minus, let's see, minus T of F. Now I call this T of F because it's a force of T. We're looking for T, remember. But why do we do minus? Because it's in the opposite direction. We multiply it by what? 0.035. Why is that? Because it's the distance away. And then we add the RF, the force of that guy. But guess what? We're multiplying it by the distance away from the pivot point. It's like right on the pivot point at 0. And you get that equal to 0. Alright, so multiply it all out, and essentially all you're doing is, if that's 0, you just put this T of F on this side, and then you multiply this and divide it by 0.35, and you get the T of F equals 166, about 166. So you got the T of F, right? And that's just essentially just T. So T is equal to 166. But guess what? You also have been given C. That's what you started with. Now if we just draw a summation of forces in the y-axis up and down, we've got C minus T plus R equals what? 0. And we've got C and T, right? So all we have to do is solve for R. So C minus T equals negative R. We plug in C, which is, for me, it was like I said, equals 50. Oops, gosh, 52.8. Sorry, this is so sloppy tonight, guys. This is new, and I'm trying to make sure I work on my handwriting. 52.8 minus 166 equals negative r. And you get about 113, or negative 113 equals negative r, and then r is equal to, divided by negative 1, 113. And that's it, and you've got your two answers. 1, 2. Remember, all you're doing is a summation of torques, and it's the radius times the force in a certain direction, and they're equal to 0. And then for the second part, you're just looking at summation of forces. That's it. Cool. Thanks, guys.